In this video, we're going to take a look at the derivatives of sine x and cos x. Our two basic formulas are that the derivative with respect to x of sine x is cos x, and the derivative with respect to x of cos x is equal to negative sine x. These two formulas come from the limit definition of the derivative. So whenever we're developing a new formula for a derivative, the explanation always comes back to the limit definition. Now, first thing we're interested in figuring out here is what the derivative of something like sine x cubed would look like. So this is sine of the function x cubed. Well, let's see if we can write our function, let's call it y. Let's write it as sine u, just to make things a little bit easier. And u here represents this inside function x cubed. So y is the function sine u is x cubed. Well, let's write down what the derivatives of these functions look like. Derivative of y with respect to u, according to our derivative formula, up here, whenever we take the derivative of a sine function, we get a cosine function. So derivative of sine u is going to be cos u, and derivative of u with respect to x is going to look like 3x squared. Now we can put these two ideas together because remember what we're trying to find here is dy by dx. So we want to figure out what is the derivative with respect to x of our function sine x cubed. Well, according to the chain rule, that is dy by du times du by dx. Okay, so that comes from the chain rule. And again, we can think of the du's here on the top and the bottom as canceling out, and that's a good way to visualize the chain rule. So what we've got here then, dy by du is equal to cos u. Okay, well, instead of writing cos u, I'm going to write cos of x cubed, just so that we're giving our answer in terms of x, because remember, u is just x cubed. And we're going to multiply that by du by dx, which is 3x squared. So let's focus on the general pattern that we're seeing here. To get the derivative of something like sine of x cubed, the derivative worked out to cos of x cubed times 3x squared. So if we try to come up with a general pattern here, what we've got is the derivative of the outside function, keeping the inside function the same. We've just taken the derivative of the sine function and made it cos of x cubed, and then multiplied by the derivative of that inside function. So derivative of the x cubed. And that is a good general way of visualizing how the chain rule is going to work with trig functions. So let's try another quick example here. Let's say we wanted to take the derivative with respect to x of something that looks like cos of 1 plus 5x. Now, without going through this whole calculation here, we want to avoid all these steps here and just come up with a quick answer using this general pattern that we developed. So we're going to take the derivative of the outside function. Derivative of cos is negative sine. We're going to keep the inside function the same. And then we're going to remember to multiply by the derivative of the inside function here. So just multiply by 5. Okay, now as we get a little bit faster at this, we may actually write our answer down in a single step. And it's always good to put any constants that we have just right at the front because it's a little bit easier to read. So we could write this as minus 5 sine of 1 plus 5x. And there's our final answer there. For our next example, our function f of x will be the function cos squared of x over 3. And the problem here is to find f prime evaluated at the x value pi over 2. Well, notice that in our function here, we've got a positive power here sitting on our trig function. And this notation here, it's just a little bit of shorthand notation, but what it really means is that we've got our function cos of x cubed all raised to the power 2. So whenever we see a positive power like this sitting on our trig function, I would suggest that the first thing we do is always rewrite that function. When we go to take the derivative, we'll have to use the chain rule, and identifying the outside function is going to be really important. So writing our function this way or rewriting it this way will help us when we go to take our derivative. All right, so let's start finding f prime of x. Well, we do have a chain rule going on because we've got some complicated function raised to a power. So let's deal with this outside function, this square function first. The 2 is going to come down in front. We're going to keep the inside function the same. Technically now the power on here is going to be 1, so you can write that 1 if you find it a little bit more clear. We don't really need to write the 1 there. So we've taken the derivative of the outside function, keeping the inside the same. We now need to multiply by the derivative of the inside function. Now I'm going to choose to do this in the next step because I know that finding the derivative of this cos function is going to be complicated enough. So I'd rather break it up into 2 steps here. Alright, so that first step came from the chain rule. And now to go on to our second step, we can start to simplify things as we're recopying here. So we could just write 2 times cos of x over 3. That looks a little bit simpler. And we now need to figure out this part here, the derivative of cos of x over 3. Well, again, it's going to be another chain rule because we've got an outside function, a cos, and an inside function that's more complicated than just an x. We've got an x over 3 in there. So the chain rule says take the derivative of the outside function. All right, so derivative of cos is negative sine. Keep the inside function the same. So we've got minus sine of x over 3, and we need to multiply by the derivative of the inside function. So that's times 1/3. So now this part here comes from using the chain rule to find that derivative in our previous step. And at this point, we are finally done the derivative calculation. So just a little comment here. Something that's often confusing here is just the notation that we're using. So notice that in our previous step here, we said we had times the derivative of this cos function. So when we went and calculated that, we've really got times, or multiplication operation here, times whatever this derivative works out to. Now, in this case, the derivative is negative. So we really want to multiply by negative sine of x over 3. It is not a subtraction that we're doing here. It's like multiplying by -1 times our sine function. So if you feel like you're going to get confused about that, feel free to put an extra set of brackets on there. Just makes it a little bit more clear that it is multiplication. All right. So to simplify this, let's bring all our constants to the front. We've got a 2 times a -1 times a 1/3. So that's a -2/3 out in front here. We've got cos x over 3, and that's also times sine of x over 3. Okay, so there's a fairly simplified version of our answer. And remember that what we're trying to do in this problem is actually plug in a value. So as soon as we've got it reasonably simplified, we might as well jump into that part of the calculation. We want f prime of pi over 2. So plugging in, here we get -2/3 times cos. Okay, if you want to think about what this value is going to look like, it's going to be pi over 6. We're taking pi over 2, which is our x value, and we're dividing it by 3. So you can think of that as multiplying by a third. Pi over 6 is going to be our angle here. And then we've also got sine of that same angle there. So pi over 6. And we've just done a little bit of intermediate calculation here in case you find yourself getting confused about the fractions. All right, so now to plug in, let's go down and think about our special triangles here. So let's draw a big triangle here. The one we're interested in is a triangle that's going to involve pi over 6. So we'll just label our angles here. So we've got a right triangle that involves angles pi over 6, pi over 3. You can think of pi over 6 as 30 degrees, pi over 3 as 60 degrees. But it's really better for us to be working in radians as much as possible. So I'm going to emphasize the radian approach here. Okay, this triangle has side lengths 1, root 3, and 2. Just make sure that the biggest side is opposite the biggest angle. So biggest side is 2, medium length side is root 3, and then 1 is the smallest side opposite the smallest angle. All right, so cos of pi over 6 is going to be adjacent over hypotenuse, according to SOHCAHTOA. To get cos, we go adjacent over hypotenuse. So if we circle or highlight our pi over 6 angle, here it is. Adjacent over hypotenuse is going to be root 3 over 2. Okay, and sine of pi over 6 is going to be opposite over hypotenuse. So that will be 1/2. So let's take our two values and go back to our calculation here. F prime of pi over 2 is going to look like minus 2/3 times cos of pi over 6, so times root 3 over 2, and then times sine of pi over 6, which is 1/2. Okay, we could do a little bit of simplifying here to get our final answer. So 1 factor of 2 from the numerator and the denominator will cancel out, and we'll be left with a minus root 3 on top and a 6 in the denominator. Just make sure that when you're giving an answer involving square roots that you haven't got any square roots in your denominator. So we always want to rationalize the denominator in this type of problem. In this case here, it wasn't an issue. No square roots in the denominator.